So today we're going to talk a little bit about logarithms, and we're going to include some inverses. So make sure you have your notes handy. So all I've done here to start with, is I wanted to color code this so you can see where stuff goes. So you can see as a logarithmic form, it's got the word log. And this is a math function. It's a button on your calculator. Logs will have a base, which will be a subscript, and then you will always have log with some base and of whatever number this is, and that will equal this answer. Now you can change that to exponential form, and when you do that, notice the base now becomes the regular number, the answer becomes an exponent, and it equals what we were taking the log of. So when we are going to do this assignment, we're going to be switching these back and forth a lot. So that's what we're going to do here and here is switch these back and forth. Now, logarithms and exponentials, why we're doing these together is because they are inverse operations. They're inverse operations and they cancel each other out. So notice if you have some base and then you have log with that same base, they cancel of a, that cancels each other out, and all that's left is this little a. Same thing if you have log with some base of that same number. So notice b and the base and the b have to match, and then it will just end up being whatever you're taking that log of, and whatever this exponent is. So those cancel each other, which is why we're talking about them at the same time. So you'll notice in this problem, we have 3 to the 4th, and that equals 81. So this is an exponential form. It's like this. So we've got our b, our base is 3. Our base is 3. It's being taken to a power of 4, and right now it equals 81. So as I change these around, I'm going to change it from this form into logarithm form. So I need to write the word log. Then log has a base, that's whatever the regular number was. So my regular number was 3, so my base would be 3. That's a subscript. Then these two switch places. So the 4 and the 81 are going to trade places. The 81 will be on the same line as the log, and then that will equal whatever my exponent was, in this case, 4. Okay, so why don't you pause this and try to do this one on your own. To change it to a logarithm form, you need to write the word log. Then the 4 was your number. It's now going to be the base. And the 1/16 and the -2 are going to trade places on the equal sign. So on your assignment, you'll have quite a bit of just flipping it back and forth. So when it says rewrite, that's all you'll be doing is trading the way it looks. So again, we have some rewrite ones. Rewrite this one as exponential equations. Also, don't forget that over here, why was this 4 to the -2 1/16? Well, that's because it was a negative exponent. So remember, when you have a negative exponent, you need to flip the base. So flip the base. So 4, the flip or the reciprocal of that would be 1/4. But then you're taking it to the second still, but now the exponent is positive once you flip it. So it ends up being a fraction of 1/16. So when you see a fraction, that means you had a negative exponent. So we had a negative exponent. That's why our answer was a fraction. So we need to write something here, because this you see log, but they don't have a base written. So go back up here, and we need to write the common logarithm. And this is the one that your calculator has on it. Has a base of 10. So we are used to having like exponents that aren't there being 1, but in the case of logarithm, it's 10. So if you ever see just log of x, it actually means log 10 of x. So whenever you don't see a base, it's actually a 10. So in this example right here, we just see the word log. So that means I have a base of what? it means I have a base of 10. So my base is 10. My exponent, which one of these do you think is the exponent? They trade places, so the exponent is 3, and that will equal 1,000. Now, when it's in this form, you can check it. So does 10 to the third equal 1,000? If you do that in your brain or a calculator, yes, it does. So you can double check that one. Now over here, we're going to change it. So this is again going to be, I'm looking for my base. Which one of these is my base? 2 is my base. And then what do the -3 and the 1/8 do? They trade places. So -3 becomes the exponent and 1/8 becomes my answer. Okay, so that's all the switching back and forth for now. We're going to continue to switch back and forth. That's like the basis of what we're doing for the rest of the video. So if you don't understand that, go ahead and write these problems on another sheet of paper and try to switch them back and forth until you can get it. Okay, on this next stuff, I want you to pause the video and go ahead and write this stuff down, because these are the steps that we're going to do. I also had a typo. Instead of making that a question mark, will you change it to an equals x, please? Okay, so now that you have the steps written down, the first thing we're going to do is rewrite this. So we need to find, just like we did here, when it says log of a base, we need to figure out what that base is. So on here, hopefully you know now what the base is. It's 4. And then I want you to try to rewrite this. What would go next to the 4 as the exponent, and what would go on the other side? Well, the x was what it was equal to, so that is the exponent, and the other side is going to be the 32. So step 1 was rewrite in exponential form, which we've done. Step 2 says rewrite as the same base. Well, neither one of those numbers are the same number, so I'm going to come over here and make a factor tree for them. So if I make a factor tree for 4, I get 2 and 2. That means I can rewrite this as 2 to the power of how many I have over here. So that's 2 to the second. Then if I make a factor tree of 32, I have 4 and 8, which gives me 2 and 2, 4 and 2, and another 2 and 2. So this can be 2 to the power of how many 2's I have over here. So that's to the 5th. Need to keep my equal sign and then bring down the x. Now I can rewrite this as 2 to the 2x power, and this side is still 2 to the 5th. So now I've rewritten them with the same base. They both have a 2 because their factor tree worked out like that, and I'll make sure that the ones on your assignment do have that nice, that they come up with the same base. Now that the bases are the same, the exponents need to be also. So I can take these two exponents, 2x and 5, and set them equal to each other. Hey, sorry. So 2x equals 5, and then I will solve that. So divide both sides by 2. So x equals 5 halves, and that's my answer. Okay, next one, 64 to the 64, log base of 64 of 1/32 equals x. So same thing, we're going to make it so it is 64 to the x equals our, what we were taking the log of, equals 1/32. Okay, so now again, factor tree. We would need to rewrite them. So we wrote it in exponential form. Now we need to rewrite it with the same base. So 64 breaks up into 8 and 8, 4 and 2, 2 and 2. Okay, 1, 2, 3, 4, 5, 6. So 64 is, nope, no coming back from that. 64 is 2 to the 6th. And 32, I already have a factor tree over here. I know that that is 2 to the 5th. Now, here's a problem. Looking at my bases, I notice that they're not the same. They're not the same. So, I need to rewrite this. Actually, this should be 1/2 to the 5th. I need to rewrite this so they both have a base of 2. And right now, this has a base of 1/2. So how can I make this the same? Well, as you notice, what do you notice about 2 and 1/2? Bases are not the same, they are reciprocals. So we are going to flip and make the exponent negative. So I like this one being 2 to the 6x. I like that one. So I'm going to flip this one. Since it says 1/2, I'm going to make it say 2. Then its exponent will be negative. So over here, when I take those and set them equal, it will be 6x equals -5. Divide both sides by 6. So x will equal -5, 6. That will be my answer on that one. So if you have a fraction, it will need to be flipped and your answer will be negative. Okay, next we are going to graph some logarithms. So on here, we will have some special points. Your equations will look like y equals log with some base of x. So using this base, you will get your 3 special points. 1 over base -1, 1, 0, and base 1. Hopefully these look familiar. They should look familiar because we just used them when we were graphing exponentials. Now with exponentials, they had a horizontal asymptote. These guys have a vertical asymptote. Their vertical asymptote is at x equals 0 unless we shift it right or left. Okay, so to get domain and range on this, domain is going to be x is greater than 0. And because we have a vertical asymptote, that's where we can't cross anymore, so it's going to keep it on one side or the other. This is x is greater than 0 or whatever number that we've moved this to. So this number comes from our vertical asymptote. Our vertical asymptote is what's going to trap us on one side of the graph or the other. The range on these, you'll see, is going to be all real numbers. So you might notice that this looks familiar, but it was the domain when we did exponential, and this kind of looked familiar, but it was the range when we did exponential. And the reason why they flipped is, again, because these are inverses. So the first thing we're going to graph is y equals log base 3 of x. So the first thing we need to do is identify our base. The base is always the number that comes after the log, so it's 3. So our special points are 1 over the base, so 1 over 3, -1, 1, 0, and 3, 1. So I will go 1/3, right 1/3, down 1, over 1, up 0, and over 3, up 1. So this guy goes like that, but I'm going to take a pause before I graph the rest of this. It has a vertical asymptote at 0. So I'm going to draw that in as asymptotes get drawn in as dashed lines, and this one's vertical, so it goes up and down. So then my graph is going to get very close to that line, but it is not going to touch, nor is it going to cross. So my vertical asymptote is at x equals 0. That's that pink dashed line that I drew. My domain is going to be x is greater than something. My range is always going to be all real numbers. So where do I get the number that the domain is greater than? Well, if you look at the graph, there's no graph over here. So I will not have any x values over here. What I do have x values, though, is on this side of my vertical asymptote. So whatever number that vertical asymptote is, that will get used again as your domain because the vertical asymptote splits from where I have my logarithm graphed and where I don't. So your domain is only where your logarithm is graphed. Okay, next one. Let's graph y equals log of x and find the domain and range in the y. Oh, I didn't find the y-intercept. On this one, the y-intercept is where the graph crosses my y-axis. Oh, there is none. I don't know why we have that on there. Because the vertical asymptote is on the y-axis, it cannot touch or cross, so we do not have a y-intercept. So we're going to leave that one off of the next one because there is not a y-intercept. And we can write that on there. None because the y-axis is a vertical asymptote, which a graph does not touch or cross. So let's get on to this one. Y equals log of x. Well, there's not a base here. So maybe if you need to, flip back. I've told you before what the base is when there's not a base. So if you flip back over here, you'll see that when you have a common logarithm, it has a base of 10. So if you have just log x, it means base 10 of x. So our base in this case is 10. So I want you to write the initial points. Go ahead and pause the video for a second and try to write your initial points. I know some of you didn't do it. Please try to do stuff when I give you time to do it because I really want to make sure that you can do it now so you can make sure that you can do it on your assignment. Okay, so when I graph this, I'm going to go over 1/10. That's not over very far. And down 1, over 1 and up 0, and then from 0, 0, right to 10 and up 1. And did I shift this left or right? I didn't, so my vertical asymptote is at x equals 0. So I'm going to draw that in again as a dashed line that my graph will not touch or cross. So here my graph looks like this. And remember, it gets close to but does not touch or cross that pink dashed line. Now domain and range. Range on logarithms is always all real numbers because it goes from an arrow at the bottom to an arrow at the top. Then domain, there's no graph here until I get to this pink line, and then there's graph over here. So there's graph only greater than 0. And again, notice the asymptote and that match up. Okay, now we are now going to take those logarithm things and move them. So we are going to still use the base in our special points, but now we're going to use the transformations that we've used before. So right after the equal sign, if you have a negative, that is a reflection on the x-axis. So it will multiply all your y values, this -1, 0, and 1 by -1. If you have a number multiplied in front of the log, that will be a stretch if it's greater than 1 or a compression if it's less than 1. These two are multiplication. Notice they have multiplication. And these ones have subtraction, addition, addition, and subtraction. So by order of operations, would you multiply first or would you add and subtract first? Well, you would always multiply first. So you need to make sure to do any multiplication of your y values first, okay? Notice these multiply the y values, multiply the y values. So if you have any multiplication, it will happen to the y values. Okay, then if it happens inside the parentheses, it will happen to the x values. So right and left, we add and subtract the x values. And if it happens outside the parentheses, it will happen to the y values. Okay, so all of this shifting up, down, left, and right, this will all be addition and subtraction. Adding and subtracting to the x values if it's inside the parentheses, y values if it's outside of the parentheses. So let's try that. Okay, we have this graph. Y equals log base 4 of x minus 2 plus 3. I want to compare it to the parent graph, and then I'm going to graph both on this graph. Okay, so my parent graph would be a graph that does not have any shifts, and I see a shift of -2 and +3. So my parent graph would be y equals log 4 of x. It would have the same base, it just wouldn't have any of the shifts. So my base would be 4, so my special points would be 1/4, -1, 1, 0, and 4, 1. I would have a vertical asymptote at x equals 0. Okay, so here would be this one. So from 0, 0, right 1/4 down 1, 1, 0, and from 0, 0 over 4 up 1. So that would be my original. Okay, now on this one, this function is y equals log base 4 of x minus 2 plus 3. So what kind of shifts do I have? Well, if I look close, I can see that this has been shifted. Hang on, I'm trying to figure out what colors I want to use. Okay, so this has been shifted to the right 2 because inside the parentheses moves us right and left. And this +3 shifts us up 3. So my initial points with a base of 4 will be the same as the points for my parent function. So 1/4, -1, 1, 0, and 4, 1. So notice those are the same for now. But it's shifted right 2 and up 3. So you first need to look out here and make sure we don't have any multiplication to do. And since we don't have a stretch or compression or reflection, we don't have any multiplication to do. So we move on to the addition and subtraction. So any shifts are addition and subtraction. So if I need to go right 2, I need to take my x's and I need to add 2. So the x's are the ones that come first, so I'll add 2 to all of these. 1/4 plus 2 will be 2 1/4, so 2.25. 1 plus 2 would be 3, and 4 plus 2 would be 6. Then on my y values, I have shifted that up 3. So I'm going to take all my y's, and up 3 would be a positive direction. So I'm going to add 3 to all these. -1 plus 3 is 2, 0 plus 3 is 3, and 1 plus 3 is 4. So these are my new points that I'm now going to graph. So I'm going to go right 12.25 up 2. Right 3 and up 1, 2, 3. Right 6 and up 1, 2, 3, 4. Now I'm not going to draw that in yet because I also want to talk to you about the vertical asymptote. Now the vertical asymptote is normally at x equals 0, and it's at x equals 0 unless it is shifted right or left. Did we have a shift right or left? Yes, we did. So this vertical asymptote also gets shifted to the right 2. So whatever our graph is shifted right and left, our vertical asymptote is shifted that same amount. So our vertical asymptote will be at 2 for this one. So when we draw in this asymptote, we can see that it's moved to the right 2, and our graph, as we draw it in, will get close to that, but it will not touch or cross. So as you can see, going from the green one to the blue one, we've gone right 2 and up 3. So what would be our domain and range on these? Well, domain on this first one is going to be x is greater than my asymptote, which is 0. And the range is going to be all real numbers. Domain on this one is going to be x is greater than my asymptote. What's my asymptote? 2. And the range is going to be all real numbers. So remember, on logarithm, your range is always all real numbers. Okay, last two things, we're going to find the inverse of these functions. So y equals log of x minus 8. So as you can tell, this has been shifted to the right 8, but I want to write it as an inverse. So if you remember from 6-7, in order to write something as an inverse, you will first switch the x and y. So I'll swap these out. So it will say x equals log of y minus 8. Now that it's switched, I need to solve for y. Well, it's tricky to solve for y how it is. So what I'm going to do is change it to exponential form. So just like we did on the front page, what is the base? The base here is 10. 10, because it doesn't have a base, 10 will be taken to the power that's on the other side of the equal sign, and it will equal what was after it. So y minus 8. So base to this power equals that thing. I'm sorry I wrote it kind of weird, but that's okay. And then last, we need to get y by itself. So solve for y. And how we'll do that is get the 8 on the other side. So y is going to equal 10 to the x plus 8. And that's my final answer. Why don't you try this one? So the first thing you're going to do is switch x and y. So x equals log base 2 of x plus 5. Now I want you to try to change it to exponential form. Pause the video and change it to exponential form. This should be a y. Sorry. So it should be 2 to the x equals y plus 5. Now we need to solve for y. So we subtract 5. So y equals 2 to the x minus 5. Okay. Good luck on your assignment, and please let me know if you have any questions.